Good day to you all. I'm James Nilay of Hi2F, and with my partner Matthew Saw of Hi2F also. However, he wouldn't be here right now because he has his own stuff to do. And we would be like to discuss to you about the Pythagorean theorem. What is a Pythagorean theorem? Years ago, a man named Pythagoras found an amazing fact about triangles. If the triangle had a right angle triangle and you made the square on each of the three sides, then the biggest the biggest square had the exact same area as the two other squares put together, which can be also said as a squared plus b squared equals c squared, where c squared is the longest side of the triangle, and a squared plus b squared equals to c squared. Today, we would like to discuss to you some of the proofs that makes a Pythagorean theorem true. However, today we will be only discussing one, which is the proof 8. Furthermore, discuss why proof 8 is true. I would be discussing to you through a rotated screen. Here is the Pythagorean theorem proof number 8. Starting with the triangle 1, we add 3 more in the way suggesting proof number 7. Similarly describe triangles 2, 3, and 4. So here is the first triangle. We add 3 more. So 2, 3, and 4. Deriving a couple of ratios, as was done in proof number 6, we arrive at the side lengths as depicted on the diagram. Now it's possible to look at the final shape in two ways. As a union of the rectangle 1 plus 3 plus 4 and the triangle 2, or as a union of the rectangle 1 plus 2 and the two triangles 3 and 4. So as we see, the first triangle 1 plus 3 plus 4 and the triangle 2 for the first solution, and the second solution is triangle 1 and 2 plus triangles 3 and 4. So now, what are we gonna do? First, we have to find all the sides that need to be written. First, we need to know the easiest ones. Since the rectangle 1 and 2 has the length and width already, which is B and A, therefore we can say that the other two sides are B and A. Let me just write that down. So this would be A and this would be B. Next, we have to find the other three sides, the last three sides of the triangle, which is this side of this side, and this side. We know that this angle is this line is AA over C. Why is that? This is because since this line is similar to this line divided by this line, therefore we just have to A times A A times A over C. Here, since we know that this and this are B, therefore we dare conclude that this should also be this one should also be B times B is B times B it's equal over C, since this one is somehow the same line as this one. And then for this one, AB over C, this is because A and B is similar to A and B over C. So therefore, we put AB over C. Now that we know all sides of the triangle, we now can prove that this figure can be equal to A squared plus B squared equals C squared. But how? As mentioned a while ago, we know that we should do the triangle 1 plus 3 plus 4 and triangle 2 or rectangle 1 plus 2 triangle rectangle, which is 1 plus 2, and triangles 3 and 4, which we can make a solution of. Equating the areas we get are AB over C times A squared plus B squared over C plus AB squared equals AB plus AB over C times A squared over C plus AB over C times B squared over C equals to over 2 are the same. And this, therefore, we can simplify. First thing we need to do is to remove all the C's. But we can't remove all the C's first because it says we have an over 2 here. Therefore, we cannot remove the C right away. So the first thing we need to do is to multiply 2 to each side, which therefore says that 2 is here. So we can divide it to these three numbers. Next, we multiply each side by C, which therefore remove all the C's here, and we'll remove this 2, which therefore we get the sum or the simplified answer of 2AB times 2A squared plus 2B squared plus ABC equals ABC plus AB times A squared C plus AB times B squared C. However, we can still simplify it. Simplified into 2AB times 2A squared plus 2B squared equals AB times A squared C plus AB times B squared C. This is because we subtract ABC from this side to this side, which equals to 0. Then after that, we can still simplify this. First, we have to multiply these two and these two and these two, which would result to the answer of A3 A cubed B plus 2B squared equals A cubed BC plus AB cubed C. We could still simplify that. The answer we would get. So first we remove 2B from here and ABC from here, which leaves us to 2A3 plus 1 and A squared plus B squared over ABC and 2B. Which is the answer. But simplifying more, A squared plus B squared over C squared equals 1. Therefore, it is safe to say that A squared plus B squared equals C squared. Right here. Therefore, this shows that this theory is correct because our final answer is related to the Pythagorean theorem number 8, which we get to the Pythagorean theorem which we need is a squared plus b squared equals c squared. So this is what we did. Here